How do we find the distance between a point and a line? Well, it depends on if you're talking about a line that exists in two-dimensional space or three-dimensional space, because those processes look very different. So in this video, we're going to cover the two-dimensional scenario. If you want to know how to do this in 3 dimensions, watch the next video in the playlist. So let's say you have a line, and the equation of the line is ax plus by plus c is equal to 0. And if it's not written in this form, you can go ahead and change it to this form. And now let's say you have a point. Okay, we'll call it point P, and point P has the coordinates x1, y1. Well, there's a very nice formula that we can use that says the distance between a point and a line will equal the absolute value of a times x1 plus b times y1 plus c, and that whole term is divided by the square root of a squared plus b squared. So we have this nice formula we can use to find the distance. Now, it's important to note that if you have a line like this and there's a point over here, you might be saying, well, this could be the distance between the point and the line. This could be the distance between the point and the line. So could this over here. And these are all clearly different distances. So what distance will this formula here actually give us? Well, it'll give us the shortest distance. So if you have a line and you have a point and you make a line that goes between that line and that point and they meet at 90 degrees, so those lines are perpendicular, this is the distance that this equation will give you. This is the distance d. It is the shortest distance. Okay, so let's do an example. So you can see my graph here I've drawn up in Desmos. I have a line and I have a point. The equation of this line is 2x minus 5y plus 4 is equal to 0. And this point P, exists at the coordinates 1, 3. Okay, and again, the distance we're looking for is this distance here. I'm using a blue vector here just to represent that distance. That's the measurement we're trying to find. So let's go ahead and use our formula. The distance is equal to absolute value of a, so a in this case is 2, multiplied by 1, right? A times x, plus b in this case is negative 5. So you can say negative 5 multiplied by y, which is 3, plus c, which in this case is 4. Divide all of that by the square root of a squared plus b squared. So 2 squared plus negative 5 squared, just like that. And now all we have to do is compute this. So 2 times 1 is 2, negative 5 times 3 is negative 15, and then you have 4. So what's 2 minus 15 plus 4? That would be negative 9, right? So all this together here is negative 9, but remember, we have to take the absolute value of that. That means we take the positive. So instead of negative 9, we're going to take the answer positive 9. Okay, that is divided by, what is this down here? 2 squared is 4. Negative 5 squared is positive 25. 25 plus 4, that's going to be square root of 29. So this is your distance. If you'd like an approximation for this, you can do the calculation, 9 divided by the square root of 29, and you get approximately 1.67. I'm rounding that answer off, of course. And so if I pull up my drawing again, you can see this blue line here. This should have a distance of 1.67. And if you're looking at the picture, I think that answer makes sense. You can see from here to here, that's about a distance of 1. So yeah, our blue line looks like it's a bit bigger than that. So the final answer, I think, seems pretty reasonable.